This question comes from Maya, who asks, what would happen if the moon vanished for exactly 24 hours, then reappeared right where it started? Would we even notice, or would the whole planet be thrown into chaos? Let's say the moon blinks out of existence at the stroke of midnight. No debris, no flash, just gone. 24 hours later, it pops back into its exact orbit as if nothing happened. The first thing to know is that gravity doesn't travel instantly, but it's incredibly fast. Changes in the moon's gravitational field would ripple outward at the speed of light, reaching Earth in about 1.3 seconds. So for a little over a second, you'd still be feeling the pull of a moon that wasn't there anymore. The first real effect would be tidal. The moon is responsible for about 2/3 of Earth's tides, with the sun providing the other third. The instant the moon's pull vanished, our tides wouldn't disappear. They'd just shrink down to the weaker solar tides alone. This wouldn't cause a tsunami. Ocean water has enormous inertia, and tidal bulges are already moving bodies of water, not static piles. The change would show up as unusually weak tides for the day, what sailors might call a moonless neap tide, with high tides barely rising and low tides barely falling. In a handful of places with unusual coastal geometry, like the Bay of Fundy in Canada, which normally sees some of the biggest tides on Earth, the sudden drop in tidal range might actually be noticeable to people working the docks. Elsewhere, you probably wouldn't notice a thing. The next thing to consider is Earth's wobble. Most people don't realize this, but Earth doesn't simply orbit the sun. Earth and the moon orbit their shared center of mass, called the barycenter, which sits about 4,700 kilometers from Earth's center, still inside the planet. As a result, Earth's center traces a small monthly loop, drifting at around 12 meters per second around that point. If the moon disappeared, that pull would vanish, and Earth would simply continue in a straight line at whatever speed and direction it happened to be moving, the same way a ball on a string flies off straight the moment you let go of the string. In practice, this just nudges Earth's orbit around the sun by a tiny amount, not enough to change the length of a day or a year in any way you'd notice. What about nighttime? This is where you'd actually see something. Without the moon reflecting sunlight back at us, nights would simply get darker. A full moon provides roughly 0.1 to 0.3 lux of light, around 1,000,000 times dimmer than daylight, but still bright enough to read large print outdoors or cast shadows. Lose that, and for one night, stargazers would get a spectacular bonus. With zero moonlight washing out the sky, faint stars, the Milky Way, even satellites would suddenly be far easier to see, even from cities with moderate light pollution. The dark would matter more to wildlife than to us. Many nocturnal predators, like owls and lions, hunt more successfully under moonlight, while their prey tend to hide more on brighter nights. For one moonless night, prey animals would have an unusually safe night, and predators would have a harder one. Coral species that time their spawning to specific moon phases wouldn't be thrown off by a single missing night, since they respond to longer lunar cycles, not one night in isolation. Could the missing moon mess with technology? Satellites that orbit Earth would be completely unaffected, since they're held in place by Earth's gravity, not the moon's. GPS would work exactly the same. The one group of scientists who'd immediately notice are the ones running lunar laser ranging stations, observatories that fire lasers at reflectors astronauts left on the moon to measure its distance with millimeter precision. For 24 hours, they'd get nothing back, and probably a very confusing morning meeting. What about earthquakes? There's a real, if modest, correlation between lunar tidal stress and the timing of small earthquakes and volcanic tremors, since the moon's pull squeezes and releases the crust slightly as it passes overhead. Removing that stress for a day wouldn't trigger anything dramatic. If anything, you'd expect a very slight, very temporary lull in the smallest tidal-triggered tremors, not enough to register outside a seismology lab. Now here's the part where the story gets fun. After 24 hours, the moon reappears, instantly, in the exact spot it would have been anyway. Gravity ripples back out across the solar system at light speed, and 1.3 seconds later, Earth feels the familiar tug again. The ocean's tidal bulges, which had relaxed slightly without the moon's extra pull, would suddenly get squeezed again, like a slack rubber band snapping taut. This would cause a brief, sharp jolt in tidal currents, noticeable to ships and coastal instruments, but again, nothing close to a tsunami. The ocean's inertia is just too large for one day,